and then some communication window. Okay, yeah, let's start. So we have 2 more lectures to go, including this one. So the lecture next week will be our last one, and then the 2 final weeks will be dedicated to the game programming, which is about using all the skills you have acquired during the course, and which is also an example of using an external library in your programming. So basically we have some new things today, and then next Thursday, and then we'll be done with the new features, and then it's all about just putting them to good use. So last week we sort of concluded the object-oriented programming. We talked about the inheritance, the class hierarchies, how we can utilize common superclasses in subclasses and things like that. And then related to that, we talked about visibility and about the problem that we may have. We may want to hide some properties from the client, like some members of the class, like attributes or methods or anything like that. But then it would be useful to access those members in the subclasses. And then we talked about that we have sort of this notation in Python for protected members, for members which are visible in subclasses but are not usable by clients. But then again, it's only a programming convention. So if we have one underscore in the beginning of a variable name or attribute name, it just tells the client that it's not supposed to be accessed, but it's still technically possible. And then we talked a bit more about the self variable, and then a bit about operator overloading, about how we can implement the functionality of different kinds of operators, whether they are comparison operators or arithmetic operators ourselves, which is definitely useful, and again makes it a lot easier for client to use our objects, for example, to compare objects to other objects and so on. So today we're going to talk about something different. And let's start with the following problem. And this is actually a problem we know how to solve, but today we're going to talk about, at least the first part is about techniques which make our life a little bit easier. So let's start with something we've been doing it before. Let's say that we have a string, something like this. Sorry. Something like this, for example, and a typical example of having a string like this is, of course, reading it from a file or whatever user input. But the basic idea is that we want to convert this string into a form where we can actually utilize it properly. And what we know by now is that we can use the split method to split the method into a list like this. So what's the problem with this one? What's the problem with the outcome? I'm sort of asking here. It's a list like this. Yeah, we still have the apostrophes, and why do we have those? What is like the main reason? What is like the, why is it a problem? I'm sort of asking here. Yeah. So we have numbers, but the numbers are stored as strings, and that may be problematic depending on what we're trying to do, but that's probably problematic because when we have numbers, we usually want to handle them as numbers. So we maybe want to do some calculations with the numbers, like calculate the sum of all those numbers or average or whatever. And what we can do, what we know how to do is something to create a new list and then iterate through the string list and then append them into new list and convert them all into numbers like this. So basically after this one, now we have a list of numbers, which means that we also can do something like calculate the sum of values or something like that. And this is perfectly fine. This is definitely something you can do even after today. But what we're going to talk about today is something like a new technique for doing this. And this new technique is it's related to functional programming paradigm, which is a sort of a new thing and for us. And it's also something very Python specific or something very Python like. So even if you don't want to use it yourself, it's useful to know how to read the code, including things like that. And what we're going to talk about today at first is something called list comprehension. And what we mean by list comprehension is that it's an expression which we can use to create a new list out of an existing list. So basically it's like saying that we have this list here, let's create a new list by utilizing the existing list. And the basic idea of list comprehension is that we utilize or we perform an operation with all items in the original list. And let's start with an example, probably easier this way. So we can do it like this, and because it's an expression, the single line of code needed to assign it into a new variable, and what it looks like, it's something like this. Something like this. And so how we're supposed to read this is that perform this operation for all these items in this sequence. So this operation typically includes this variable in here. So it's like saying that perform this expression for all items in the sequence and store them into a new list. So when we execute this one, we can see that we now we have the sum, it works, but we also, if we output the list, we get the same list, including all the numbers in the list. So basically what we're saying is in this specific case is perform this int operation, this int conversion to all items in this list parts. So what this means is that the list comprehension is basically just like an alternative way to perform the operation we already know how to perform. But this can be useful. Well, as I said before, this is something that's used quite often in Python programming. So it's definitely useful, at least to know how it works. But it's also useful in a sense that it's an expression. So you don't need a loop which includes several statements. And an expression is something you can have as a part of another expression. So it can make your code definitely shorter, but also more readable and more convenient in some cases. So let's see some other examples to actually see the full benefits maybe. So let's have some numbers list like this. So what will the program output? Yeah, that was a quick one. So basically now the operation we're performing is x plus 1 for all values x in numbers, which basically means that we increase all the numbers by 1 and store them into another list. So in this case, we have a list with items 2, 3, 4, 5, and 6. Because this is an expression, we can also create a list in print statement if we want to. Which means that we don't really need any alternative variable for storing the list, which can be useful if you only need the list for some occasion. We can only do also do something like this. for example, which means that we generate the new list sort of online in this for statement, so it only exists during this for loop. And this new list, we utilize the list comprehension, and what we say in this case is we take all the items in sequence numbers, in list numbers, and multiply them by 2, and then we iterate through them by using the for statement. Which again, something like this again might be useful in some occasions, or definitely is useful in some occasions. And again, this might be useful in a sense that if we don't need the actual list, if we only want to iterate through the items multiplied by 2, then we can do it something or similar to this one. Of course, we could also do something like this, which is equivalent to that one. And the upside for this one is that we don't need to use the memory, which we need in the previous one to store the list generated by the list comprehension. Okay, let's have one more example. Need to have Bob in the So basically what this outputs, you don't need to type all the values, but what is the basic idea? Yeah. So again, similarly, it performs the same operation for all these variables in here. So it converts them all into uppercase. So again, something this might be useful in some occasions. Okay. So yeah, something about materials, something if you take a look at the material, there are some pictures there which still have a couple of lines of finished text. And this is unfortunately because we have, for some reason, someone, might have been me, or it might have been someone else, has lost the original images for this part, and we weren't able to translate them. We're going to redraw them, but nobody really haven't had time yet. Fortunately, these are sort of easy to understand, even if you don't understand any Finnish, but that's a bit an inconvenience at least. Anyway, this sort of this figure so sort of here displays what happens in list comprehension. We have a sequence here on top, and then all the items in this sequence go through an operation in here, and then those the result of operation for all items is stored into a new list. Basically, list comprehension always creates a new list. We can do whatever we want in the list comprehension because it's this one, the first part in here is an expression. So what it means is that we could have a function we call something like factorial, for example. And then we could have a list of numbers again. And do something like this. And then we can see what are the factorials for all those numbers. And here they are. So what I'm trying to demonstrate with this one is that this first part of list comprehension, this expression can include anything you want. It can be any expression in Python. It can be actually even, well, whatever you can include in expression, you can include over there. So basically it performs this operation for all these items in the sequence. Okay, list comprehension also has other things we can do, and it also supports filtering of the items, which means that we don't need to perform the operation for all items in a list. Let's have a little bit longer list in this case. Let's see what it looks like. So we have basically have items from 1 to 100 like this. And let's say that we want to pick all the items from existing list which are divisible by 3, for example. And we can use list comprehension for that one. And what we can say in this case is that the expression we're going to perform is just, it doesn't actually do anything. It doesn't manipulate the item anyway. Let's say item item for item in numbers. So basically this list comprehension in this form just creates a copy of the original list. But what we can do is we can extend this this mechanism by having an if statement at the end, something like if item is divisible by 3, for example, or if item modulo 3 is equal to 0. This is something we've been doing before. And now if we see what we have, something like this, we get a list including only the numbers, only the items from the original list which are divisible by 3. We can also extend this one to only pick the items which are divisible by 3 and 2. So only the even items. That's a good question. Is it possible to write item if item modulo 3 equals 0 for item in numbers? Now, this is the basic way to do that, but there's another sort of alternative thing we can use, sort of similar to that one. But only if we are filtering for items, then we include the part at the end of the list comprehension. So let's see, item if item. And you can see, so this is an error which we can see that's which one it's expecting something, and this is actually something I'm going to talk about in a minute. But this specific syntax like this doesn't work. Okay, filtering items is definitely useful, and it's also something that's used quite a lot with list comprehension. At least I am, and I know a lot of Python programmers are, because it's so easy to pick only the items we're looking for from the original list. So we can use whatever if statement we want at the end, and the idea is that we just write a statement which is used for all items in a list, and if the statement, or if the value of the statement is true, then the item is included in this list, and then the item, well, actually, yeah, let's see. Well, let's have the even items at this point. So basically, well, all the items which are divisible by 2, we can also include an expression for this one. We can do something like this. So what it means in this case is that we take all the items from numbers which satisfy this condition, meaning that all the even items from the original sequence, and then if this is true for the item, then we include it in the list. But before we include it in the resulting list, we perform this operation, this expression for the item. So we basically have all the even items from the original list, but then we add 1000 to all those items. So you can also combine this for those items. Okay, then something related to that question we had a couple of minutes ago. Let's remind ourselves first of this conditional expression, which I think we talked about quite briefly. But anyway, in Python, we can use something like rid of that one, rid of everything for a minute. Let's do something like this. Let's query a number from a user, and then we can do something like this. And you remember this one, do you? Don't you? Do you remember this one? Or something similar to this one, like this construct or this mechanism? Yeah, okay. At least someone is, and the basic idea in this one is that, well, what happens here is if I give an odd number, it displays is odd, and if I give an even number, it displays is even. But the basic idea for this expression is that it gets a different value based on this condition here, which is again useful, for example, if we have an output where we want to concatenate another part, and that part depends on some variable values or some whatever conditions in our program. So basically this means that again we can have it as part of an expression instead of having an if-else statement where we have two separate print statements, for example. But we can utilize this expression with list comprehension as well. So let's have a list. Something where we have negative values and positive values, sort of random. At least they appear to be sort of random. And what we can do is do something like this. For example, we could state that let's pick an item if item is larger than 0, and if it isn't, let's take the negative value item for all items in, we don't want to call it a list because that's item in number list. So basically what we're doing is, again, we have a list comprehension, and again, we have an expression in the beginning, but we can utilize the conditional expression we used a minute ago in this one as well. So what is the result of this one? What does it do? Yeah, they're all positive numbers. So basically what we have, if we execute this one, is well, this one of course gives us the original list because I'm using the wrong variable name, but we execute this one, then we get the absolute values of all of these. So all the negative values in the original list are converted into positive values in the resulting list. So we do have the ABS function in Python, which we can use to perform the similar thing, but it's just an example that we can perform a different expression based on some condition for all the items in a sequence quite easily. And this is also useful in a lot of occasions. A lot of occasions we want to perform something to some of the items and then just preserve some of the items in their original form, or perform entirely different operations for items based on some condition, some like single condition. List comprehensions are also great in a sense that they accept any sequence. So we could do something like this. Let's start with really something basic. So what we have here is we just have all characters in this string as a list, which is basically, well, there was a question. So you can use pass for the else part too. Yeah, we can use pass for the else part. But if you're using pass for the else part in the previous one, if you're doing something like if you're doing something like no, actually you can't use pass. And the reason you can't use pass is because it's an expression in this one. So it's like expression if something is, if condition and else another expression, and pass is not an expression. Pass is a statement which doesn't do anything. So you need to have a value, something that something that results into value in this one, like C, or you can use none if you want for this one or something like that. But you need to have some kind of value or some kind of expression that can be evaluated into a value. Anyway, let's get back to this one. So we basically have a list of all characters in a string. Well, if you only want to do that, the easier way to do that is probably to do something like this. This performs the same operation, but what's useful is that we can utilize whatever expression we want for this one. We can do something like this, for example. So in this case, we have a list of all the characters, except that all the characters are converted into uppercase versions. And we can also utilize the filtering of this. So let's say that we only want the vowels from the original message. So we can do something like this, or it's those all the vowels, maybe. Do something like this. So now we only have all the vowels in uppercase form from the original string, which is displayed in here. And so utilizing list comprehension with strings can be highly useful as well. So again, we can perform sort of complicated operations with a single expression. Now something to think about, well, let's do something like, nothing can't seem to hit the right keys today. Okay, what happens here? Just take a minute to look at the code and try to understand what's happening here. Yeah. So basically, that was a quick one, really quick answer. So basically, what we're doing here is we're utilizing the split operation, which we're, like we earlier found, it's a really great, for example, if you want to split a sentence into individual words, like in this case, and then we utilize the list comprehension, and we pick all the words, and for each word we start from the second character in there. What happens now? Yeah, we talked about the join operation briefly when we talked about reading data from files. And I don't know if you remember, but the idea of join operation is that we can use it to convert a list of strings into a single string. And basically, the idea is that we define the delimiter which is used in the join string. So basically, what we have in this case is the original sentence, except that all the words are missing the first character. And we can perform this with a single expression. And now list comprehension can be a really powerful tool. And for example, with strings, especially when we combine it with, for example, with join operation and a split operation and things like that. But this is also, it can also result to really complicated expressions. And I think this isn't the worst one, but even this can be sort of difficult to read and understand. So there's nothing wrong in performing this in like several or with separate operations one by one, and with separate consecutive operations, something like split it first and then iterate through it or something like that, because this can be really difficult to debug later. There was a question and an answer, as it seems that would res aria still be a list here? And no, it isn't. The join converts a list into a string. So this is res is a string here, which we can see if we perform this one. It's a class str. If you don't remember how the join works, we can see a couple of examples about that one. Say we have a list of names, John and Bob and Andrew for some reason. So if you want to combine this in the new string, we can do something like this. So with join operation, we first give the delimiter. So for example, space, and then it's join and names. So this one just, in this one, the items in the original string are joined by using a single space as a delimiter, but we can use something else, like a comma, for example. Comma and space probably provides a nicer looking list. Or semicolon if you're writing this into a file, or something like and. So we get a John and Bob and Andrew. So basically whatever string we want to, in this case. So it's useful in a lot of occasions, but it's also useful when we are splitting a string into a list and then joining it back together into a string. So let's see something else. Something like this. We're missing a character over there. So change this a little bit so we don't need to include all the ifs. So what happens here? And as I said before, these can get quite complicated, and this necessarily isn't something I want you to write. This isn't the kind of code I want you to write, but it's just an example to show you that you can perform rather sort of complicated operations. So in this case, it converts the first and final item into uppercase, and then in this case, the S isn't in uppercase because it performs the uppercase operation for the comma. Yeah. So if you want this to work, then we probably need to get rid of the commas and whatever whatever characters and then perform this operation as well. So it might get even more complicated. But still, the basic idea is that list comprehensions and can be really useful when you're dealing with strings. And myself, for example, I use it quite a lot. I think this is sort of a basic thing I do when I'm manipulating strings. I usually split it into by using whatever delimiter, and then I use the list comprehension, and then I can join it back together quite easily. So this can be really useful. We can do something like this. So let's see another example. So what is the outcome of this one? Yeah, so it gets rid of all the vowels in a word. So even though this specific case might not be what you want to do, because vowels are usually quite useful, but something similar might be useful. It's quite common that you want to filter out something from a sequence, whether it's characters from a string or any items from a sequence. So as I said in the beginning, you can perform these same exact operations without using the list comprehension. But the list comprehension is sort of a handy way to do this. Okay. So the comprehensions also work with dictionaries. Let's see something like, let's have a list of words again. Something like names. Some the same names. I can't remember which one they were, Bob and Jane. And yeah, dictionary comprehension. Something like this one. Andrew. Well, this one. And let's say that we want to have a dictionary where we have the names as keys, and then something like the lengths of the names, for example, as values. We can do something like this. Well, the traditional way would be to create an empty dictionary and then iterate through all the items. But we can also do something like this. Sorry, something like this I meant. And then we have an extra. Oh, the parenthesis was over there. So basically, the syntax is really close to list comprehension, but since we are creating a dictionary, in this case, we need to have both the key and the value for this one, and then we surround it with these curly brackets, are they, which we denote or use whenever we are creating a dictionary. So basically, what we have for this one is something like this. There was a question, are we going to discuss the colon equals operator? Not probably, no. There's something specific. I'm not actually sure what you mean by that operator in Python. Oh yeah. Yeah, it can be used in list comprehensions. No, we can actually discuss it briefly at the next time if we have time, because we're going to talk more about the functional programming at next week, or about more. And I think it's sort of a better fit over there. But when we talk about the yield, for example, and generator functions, but not really that much. It's not included in the material. I think we discussed it briefly when we were writing the material, and then we sort of agreed that we're going to leave, we need to leave a lot of things out. There are a lot of things happening in Python not included in this course, but it's actually something I don't use that much myself. I've seen it, but that's a good question anyway. And I think it's a good example that whenever you're using whatever we're discussing in this course, it's important to realize that there are a lot more going on with all of these features. It's still like a limited list of things we can include in this course, and it's a good idea to Google for these things and check the Python documentations and things like that to find out what kind of other features there are. Anyway, about the dictionary comprehension, I'll look something like this. So we have the names and the length of names stored in the dictionary, but the basic mechanism is similar. You can use filtering for this one if you only want to include some of these. This one is. So we can do something like this if you only want to include the names that include a lowercase o in their name or something like that. So yeah, the basic mechanism is really similar. Let's see if I forgot something. There's a filtering calling the function. We had the alternative branch. We talked about iterating through strings and join methods and split and dictionary comprehension. I think that's basically. Is there anything you want to ask about the list or dictionary comprehensions, or any other examples you want me to show or something? Because there's another topic we also need to discuss today. It's a bit more complicated, but it's also something we're not going to get that deep into. Okay, if there's nothing, then we are going to talk about a little bit more about calling functions, and we're going to talk about a specific sort of concept called recursion. Something we've been using before in a lot of different tasks is the fact that we can write functions that call other functions. For example, let's see something like so we could write a function that returns the number of vowels in a string. And again, we can utilize list comprehension for this one. So we basically create a list out of the string containing all the vowels, and then we return the length of that one. So it basically returns the number of vowels in the string. And then we can utilize this to create other characters kind of function. So we've been doing things like this before. You know that when we have several functions, we can utilize functions in other functions. So if we have a function that calculates the number of vowels in a string, and then we want to have a function, we need to have a function that calculates all the other characters in a string. There's no point in, we can utilize this one over here. We can just take the length of the string and then subtract the number of vowels in a string from that one. So this makes our lives easier. But because functions can call functions, it must mean that function can call itself as well. And let's have something like this. Oh, sorry. So what happens in here? Yeah, exactly. So if you take a look at the function, well, if you take a look at the main program first, what we do is we initialize a list with 3 items, 1, 2, 3, and then we call the function add item. And in the function add item, we receive a list of numbers as an argument. Then we add a new item at the end of the list, in this case value 10, and then we call the add item again. And what it seems to be doing in this case, it adds the item for infinite times. Well, actually, it doesn't do it infinite times because if we execute the program, then we can see that we get an error stating that it's a recursion error, maximum recursion depth exceeded. Yeah, that's a good example. You can actually take a look at that. So the basic idea, if we get a little bit back to that one, is that we can set the variable inside this list comprehension. Again, that might be a bit complicated, but I think it's performing a quadratic equation over there. As it actually says there on the top of it. But yeah. So it basically sets the discriminant for variable d in this case, and then it utilizes it over there later in the expression. And yeah, I've seen that one before, and I think it might be useful, but it also can make those expressions really complicated to sort of debug. So you need to you definitely can utilize that one, but just sort of be careful about that one, because it might make those really hard to debug, because there's no way in, for example, in displaying the value of this variable between these changes in this whole thing. Anyway, let's get back to this one. So basically, we have what we have here is a recursive function. So recursion basically means that the function calls itself, or group of functions calls the same group of functions, something like that. But recursion basically means that the function keeps calling itself. And so this one obviously doesn't work. And the problem with this one is that it never stops. It's like an infinite loop, except it's performed with recursion. So a basic rule of a recursion is that for the recursion to end, we need to have some kind of terminating condition in the recursion. There's a question, is that have ternaries been discussed? Not that much, no, I don't think so. What we can do in this one is write a condition in the beginning of function, something like and then this one. So what happens now? What does the program do? Yeah, exactly. So let's see, let's output the list after this one, and see what we have. And now we have a 1, 2, 3, and then 7 tens in that one. Or yeah. So basically, again, we have a recursive function, but in this case, we have this condition, which basically the effect is that the recursion will end at one point. So we keep adding numbers at the end of the list if the length of the list is smaller than 10. And we add the numbers, add more numbers by calling the function itself again and again and again and again until we no longer call it. And then the sort of the call stack is full, and well, the call stack isn't full, but the call stack or calling ends in this case, and then we get back to the main program. Let's see something sort of similar to this one. Okay, what happens in here? Okay, you don't need to give me the exact output or anything like that. What's like the basic idea? And before you start thinking about this, I need to mention that recursion can be, it's a difficult concept, and it can be sort of really complicated concept at first, because the basic idea is so different to what we've been doing before. And we usually talk about concepts iteration and recursion. And iteration is what we've been using in our programs until now, and it's what we're using in most of our programs starting from this point further as well. And the basic idea of iteration is the whole like the sort of the basic concept of having consecutive program statements which are executed one at a time. And then we can have things like loops where we repeat certain statements over and over again and things like that. But that's like the basic idea. And recursion is a whole different concept in a way that in recursion, we keep on calling the same code over and over again. So if we execute this one, we basically have oh no, we have something. Oh, sorry. I'm messing with the parentheses here. So yeah, that's what I was sort of supposed to do. So what's the problem with this one? Is that if the length of the string returns something, we don't return it. So in this case, we get the hello and the exclamation points. So now we had the ending condition for the recursion defined, but we didn't have a return value for the recursion if the ending condition is met. So it basically just returned none when the length of the string no longer wasn't smaller than 20. So whenever we're doing something like this, we're adding something in the sequence or removing something from a sequence. We're basically talking about tail recursion. And we can see actually something like this probably isn't useful because, well, you can perform this quite easily yourself. You can add the exclamation points yourself quite easily. Let's see something that could be even mildly useful, something like factorial. And to calculate factorial, what we can do is return n times and factorial n minus 1. So this is like the basic idea. To calculate factorial, we need to multiply the value with the value 1 smaller. And when we call this again, what happens is if we start with 10, then this one multiplies 10 by call to factorial 9, which again multiplies 9 by call to factorial 8, and then it collects all the possible things. The problem with this one is that, again, this will go on forever and ever. So exactly like we have a message in the chat, we need to set a limit for n. And for this one, we can state that if n is smaller than 2, because the factorial of 1 and 0 is 1, we can just return 1. So let's try this out. Five, and the factorial of 5 is 120, which seems to be okay. So it's 5 times 4 times 3 times 2, which is 120. Oh, the factorial of 15 is a larger number, something like this one. But the basic idea is same. Okay, so you can calculate factorial rather easily by using the iterative solution. Just write a loop where you keep on repeating the number over and over again. But if you just take a look at the code and if you understand what the recursion means, then this one might be seen as a easier to read solution. Even for someone who doesn't really understand programming, this can be sort of easy to understand because the basic idea is that factorial is n multiplied by n minus 1, which then keeps on repeating. So this basically collects all the numbers until we reach a number smaller than 2, which then returns 1, and then we have the whole sort of expression collected and the final result returned. So I think this one hopefully is sort of easy to understand, but coming up with these can be sort of difficult, and the whole basic concept of recursion can be difficult. I have an example about this one. It's from the material, the Fibonacci sequence. Spelling error in the supposed to be Fibo, but the basic idea for this one is sort of a similar. So you remember you all calculated the Fibonacci sequence. I'm thinking it was one of the exercises, or there were a couple of exercises related to Fibonacci sequences in one of the first parts, 2 or 3 or something like that. And if you take a look at this one, this is actually sort of, I'd say that the code itself is sort of more clear and maybe even more beautiful, because this is sort of simple thing. It's simple, like if n is equal to or smaller than or equal to 2, then return 1. If it's something else, then the Fibonacci value is the sum of 2 previous Fibonacci values. So call of this function with arguments 1 and 2 smaller, Fibo n minus 1 plus Fibo n minus 2. So that's basically how you calculate the Fibonacci, because the whole definition of Fibonacci value is that it's the sum of 2 previous values. And because this current function returns the sum, or returns the Fibonacci value for this n, then we know that the value is the sum of 2 previous Fibonacci values. So if we're calculating the Fibonacci value of 6, then it's basically the sum of Fibonacci values 5 and 4. And why it works is because if you take a look at this one, and you can take a look at this one in the material more in detail and with better time, but basic idea is if we call it with 1 or 2 as an argument, it returns 1 because of this if condition, or conditional block in here. So basically, if n is smaller than or equal to 2, it returns 1. If the argument is 3 or greater, then it returns this final part in here. And because it works, because if you think about the case, let's say that argument is 3. So 3 isn't smaller than or equal to 2. So this one is skipped over. And then it returns the result of course, to Fibo n minus 1 plus Fibo n minus 2, which is basically Fibo 2 plus Fibo 1. And both Fibo 2 and Fibo 1 return 1. Am I right? Tell me if I'm not right. So it's basically 2, and 2 is the third Fibonacci number. So it's supposed to return 2. If the argument is 4, then the return value is Fibonacci 3 plus Fibonacci 2, or Fibo 3 plus Fibo 2, which is again, as we saw at previous, it's like 2 plus 1, which is 3. And then the same for argument 5, and so on and so on and so on. So it works because we can prove that it works because it works for arguments 1 and 2, and because all the other values are calculated based on those values. Am I making any sense here? If this seems complicated, if it seems like sort of difficult to understand, it's perfectly fine, because it is complicated and it is difficult to understand. And the thing about recursion is that when it's used correctly, usually the functions themselves are really sort of simple and sort of easy to read, but what happens inside might be sort of difficult to understand. Now, you can use recursion to calculate Fibonacci or factorial or things like that, but you can also calculate Fibonacci and factorial quite easily by using the iterative solutions. And the iterative solutions might be more effective because function calls are probably heavier than just storing a single variable somewhere and so on. But the recursion is useful when you, for example, when you have a recursive structure. Let's say that you have a graph like this. This is sort of a, I don't know, some kind of organizational hierarchy of a company or something like that, or whatever, or things related to advertising, whatever it is. But let's say that you have a graph like this, somehow model it in your program, and you need to visit all these nodes in this graph. All of these boxes are called nodes, which if you take more of our computer science courses, you will discuss more these kind of things like graphs and trees and things like that. And writing an algorithm that visits all these nodes in iterative way can be really complicated, because you need to somehow keep track where have you been and where you need to go next and things like that. And if you think about that, although it may seem simple, it can be really complicated. Like do you have a list of nodes you have already visited? And if you do, how do you know which nodes have more child nodes and things like that? And thing like that can be, it may seem simple, but the actual algorithm can be really complicated. But if you write a recursive version, then it's really simple. All you need to state is that when you are in a node, call the same function recursively for the node above it, for the node left to it, for the node below it, and for the node right to that one. And then it just keeps on calling itself. So it goes over there and then it visits all of these, and then it keeps on going over there. It doesn't matter how complicated the graph or tree or whatever the structure is. The recursive algorithm is still sort of easy to come up with, and it still visits all the nodes in whatever order and so on. So we have some simple examples and a couple of more complicated examples about recursion in this week's material. And I think in the final page, there's an example of a binary tree, which is basically it's sort of a recursive structure in a sense that there are nodes, and each node may have 0, 1, or 2 children, and then those children may have more children, and so on and so on and so on. And there are examples on how the recursion can be used quite easily to visit all those nodes, or count something on all those nodes, or things like that. So what I want you to understand is the basic idea of recursion, which is that the function keeps calling itself, but the input is changed on each call. And so it gets closer to reaching the actual solution on each call to itself if it works properly. You don't need to understand recursion more deeply after this course. If you're interested in, and if you're going to take more courses in computer science, then you will at some point. You need to at some point understand it more deeply, because it's related to some of the data structures, for example, more deeply. But as I said, it can be a complicated, and in this sort of a complicated concept, and that's why we start with some basic things over here. Also, I can sort of promise you at this point that there won't be anything about recursion in the final exam, because again, it's sort of a concept that's more advanced concept, so you don't need to use recursion in the final exam. But still do the exercises, and if you understand it, perfect. If you don't fully understand it, it doesn't really matter, but just get the basic concept of functions calling themselves. Next week, we will have the final lecture of this course, and so like the 12th lecture of these 2 courses. We're going to talk about a bit even more about functional programming. What we really mean, I didn't really talk about the functional programming as a concept too much. We probably will do it next week, but the basic idea of functional programming is that we try to perform as much of the operation of the program by just having functions that call other functions and so on. So we need to try to have as little variables as possible. So when the basic idea of imperative paradigm is that we have variables where we store values and so on, in functional programming we just have functions that call other functions. So if you think about the list comprehension, that's sort of an example of functional programming in a sense that we don't need to define any intermediate variables. We just have a single expression that results into something. And we're going to talk more about things like that. And we talk about things as functions, as parameters. We can pass functions themselves as parameters to other functions. And sort of related to that are the lambda expressions, which are like anonymous functions. Then we talk about something called generator functions, which are basically means to, for example, to create a loop, but you only return one item from a loop at a time. And then some functional programming functions like map, filter, and reduce. And then we're going to talk about briefly something called regular expressions, which are, it's not really a Python thing. It can be utilized in Python. It's a more general concept about manipulating strings and getting information out of strings. It's a sort of messy syntax, but they can be really powerful. You can do really impressive things with like a single expression over there. So that's what we're going to conclude our lectures with. And then, as I mentioned before, the last 2 weeks you're going to perform a project with Pygame, like a sort of a small game yourselves. So any questions about anything today or anything else? You hopefully all got your results of the first exam. If you're having any problems with the results, just let me know, send me an email. Somebody had some problems in registering their result, I know, and that's hopefully solved. But if anyone else is having anything, let me know. If you have any questions, remember to use Discord. You can also send me private messages in Discord if you want to, or you can send an email or whoever. Okay. Yeah. Yeah, it doesn't really matter if the email showed you that you're registered for the course again, is as long as you got your credits for the course. So just as long as you see your credits. If you're having any problems, just send me an email. It's easier to solve that way than in here. Anyway, I'm going to stop the recording now.